So we want to know what are sine, cosine, and tangent functions, geometrically speaking. Well, when we have a right triangle, a triangle with an internal angle of 90 degrees, we have a few components that we know about that triangle. We have two other internal angles, one of which I've just picked and labeled as theta. And then we have, relative to our angle theta, the side of the triangle that is opposite, labeled opposite, and then we have the side of our triangle that's touching our angle or adjacent to our angle. And so these side lengths will have lengths. Let's say our opposite side is 3 units long, our adjacent side is 4 units long, and our hypotenuse 5 units long. Well, how do sine, cosine, and tangent functions help us out here? Well, these functions are kind of like when we see f of x. We don't see f alone, we see it given a parameter or a variable. And similarly, our trig functions here are given a parameter or variable, in this case, theta, our angle. And so what this tangent of theta or sine of theta or cosine of theta tells us is that relative to our angle theta, we get a ratio of side lengths. So our sine of theta is going to tell us what is our opposite side length divided by our hypotenuse side length. And again, this is all relative to the chosen angle. So the side of our triangle that's opposite of our angle theta is 3 units long, and our hypotenuse is 5 units long. This gives us a ratio of our opposite side length relative to our hypotenuse side length of 0.6. So our opposite side length is 60% the length of our hypotenuse. And then similarly for our cosine and tangent functions, these give us the ratios of our adjacent side length relative to our hypotenuse for cosine, and our tangent of theta gives us our opposite side length relative to our adjacent side length. So if we substitute in our values from this triangle, that gives us for cosine of theta an adjacent side length of 4 over a hypotenuse side length of 5, or a ratio of 0.8. Similarly for our tangent of theta, this gives us an opposite side length of 3 divided by our adjacent side length of 4, or a ratio of 0.75. So our trig functions here, given our parameter of an angle, theta inside our triangle, they tell us what the ratios are of the relative side lengths, depending on which function you choose.